Today, we're going to demystify Docker. We're breaking down the simple core workflow that takes your code and turns it into an application that can run absolutely anywhere. This is the fix for one of the biggest headaches in software development.
Oh, you've heard this one before, haven't you? It's that classic, super frustrating moment when your code runs perfectly on your computer, but completely breaks for everyone else. Well, this is the exact problem that Docker was built to solve, once and for all.
So what's the magic trick here? It's Docker. You can think of it like a universal shipping container, but for your software. It takes everything your app needs to run, your code, all the libraries, the right settings, the whole shebang, and bundles it all into one single, neat, portable package.
And the entire process is actually a really simple three-step journey. First, you write the blueprint for your application in a special file called a Docker file. Second, you build that blueprint into a self-contained package called an image. And finally, you launch your app by running that image as a container. That's it. Blueprint, package, launch. Let's dig into each of these.
Okay, let's start at the very beginning with step 1, the blueprint. This is where we lay out the exact instructions that Docker needs to build our application's environment.
So what is a Docker file really? Just think of it like a recipe for your application. It's literally just a plain text file where you list step by step every ingredient and every instruction needed to assemble your app's environment completely from scratch.
And inside that recipe, you'll see some common instructions. You always start with from, which says, hey, let's start with this basic foundation, like a version of Linux with Python already on it. Work direct is like saying, okay, from now on, let's work inside this specific folder. Copy does exactly what it sounds like. It copies your code from your machine into the container. Then run is for executing commands, like installing all your software dependencies. And finally, CMD is the grand finale. It's the one command that will actually start your application when the container launches.
All right, so we've written our recipe. Now we move on to step 2, where we actually cook that recipe into a real, shareable package. And to turn that Docker file recipe into our final package, we use one simple command, docker build. This command just reads through all those instructions we wrote and uses them to construct a totally self-contained, unchangeable file called an image.
Now this slide here explains the single most important concept in Docker. What's the difference between an image and a container? The best analogy is a video game. The image is like the game you've installed on your hard drive. It's the complete but totally inactive package. The container, well, that's what happens when you double-click and actually play the game. It's the live running process that's using your computer's CPU and memory.
And here's a really clever part of the process. Every single instruction in your Docker file creates a layer in the image. Now, what's so cool about that? Well, if you only change the very last instruction in your file, Docker is smart enough not to rebuild the whole thing. It just reuses all the unchanged layers from a cache, which makes your builds later on so much faster. So, we have our blueprint, and we have our packaged image. Now for the most important step. How do we actually run this thing and bring it to life? You guessed it, it's just one more simple command, docker run. This command is basically the ignition switch. It takes our static, dormant image, breathes life into it, and launches it as a live, running, active container. But wait a second, there's a small catch. By its very nature, a container is completely isolated from everything else. So, if our app is running inside its own little box, how do we actually talk to it from the outside world? The answer is something called port mapping. And here's a great way to think about it. Imagine your computer is a restaurant, and it has a bunch of tables, or ports. The container is like a private room inside that restaurant, and it has its own set of tables. Port mapping is just connecting a table out in the main restaurant directly to a specific table inside that private room, so that people, or data, can get through. And we create that connection super easily using the P flag. So for example, saying P8001/8000 is just telling Docker, hey, any traffic that comes to table 8001 on my main computer, I want you to send it straight through to table 8000 inside the container. And just like that, you've built a bridge. And along with that port mapping flag, there are a few other handy ones you'll use all the time. The dash flag runs the container in detached mode, which means it just hums along in the background so you get your terminal back. Dash name is great because it lets you give your container a simple, memorable name. And dash P, as we just saw, is how we publish those ports.
Okay, so your container is up and running in the background. But how do you check on it? How do you manage it? Let's quickly look at a few essential commands you're going to need.
These 3 are your daily go-tos. Docker PS is like asking, "Hey Docker, what's currently running?" And it'll give you a list of all your active containers. Docker Logs is awesome. It lets you peek inside a running container and see all the output from your app. And when you're all done, Docker Stop gracefully shuts the container down.
So let's just pull this all together and do a super quick recap of the journey we just took, from a simple text file all the way to a completely portable application. It all boils down to this simple but incredibly powerful loop. First, you write the instructions in a Docker file. Second, you use Docker build to create that static portable image. And third, you use Docker run to launch a live running container from that image. Blueprint, package, launch. That is the absolute heart of Docker. And this really gets to the core of why Docker is such a game changer. Once that image is built, it's a complete, finished package. The only thing anyone else needs to run your application perfectly is the Docker tool itself. That "it works on my machine" problem, it's gone, solved.
So, now that you know how to package up basically any application into a single portable unit that can run anywhere, the only question left is, what are you going to build and where are you going to run it next?